Hey everybody. So in this video, we're going to be talking about when you should use law of sines or when you should use law of cosines. So we remember this from former videos. We have the law of sines here. That's sine of A over leg A equals sine of B over leg B. And that also equals sine of C over leg C. And then we have our law of cosines. Both of these laws are used for finding missing legs and missing angles inside of a triangle. So the idea is, well, if both of them do the same thing, can't I use both of them whenever I want to? And the answer is yes, and also kind of no, because you have to meet certain criteria in order to use each of the following laws. So with law of sines, here's when you're going to want to use law of sines. When you have two angles and one side. So you'll remember this from geometry by having the postulate angle, angle, side, or angle, side, angle. You could also use law of sines when you have two sides and one angle. And this is side, side, angle here. Now, I will caution you on the bottom one, two sides and one angle. You'll want to be careful here because this is when you could run into the ambiguous case. So if you have two sides and one angle, I would recommend using law of cosines, but law of sines is possible if they tell you to solve it using law of sines. So with law of cosines, again, just like law of sines, I said I would, let's pick something else so we don't blend in with the line at the bottom. Here, if you had two sides and one angle, so that's side, side, angle. Now this one, where you have two sides and one angle, we are looking for side, angle, side. So this would be an angle in between the lengths of two legs. And then the other time you could use law of cosines is when you have three sides. So we're going to do a few examples in this video, and we're going to first state the criteria that we're given, and then we're going to determine which law we should use. So here in example 1, we're given an angle right here with 31. We're given another angle here with 36, and we're given this side length of 14. So we have angle, angle, side. So looking back at our different postulates for angle, angle, side, that's here under law of sines. So you don't have enough information to use law of cosines, because on law of cosines you have to have at least two sides of the triangle, where here we don't. We have two angles, and we only have one side. So we're going to want to use law of sines here to find the missing values. So we have one ratio. We can go ahead and set that up, that sine of 31 over sine of 14, or excuse me, just over leg 14. And now we can find the missing values, because we know we're going to be looking for AB, we're going to be looking for AC, and we're going to need to know to find angle B. So we have the one ratio set up, sine of 31 over 14. Now we can use sine of 36, and we can set that over x. Now we can find the length AB. So here we can cross multiply. And we want to isolate x. So we're going to divide by what they're multiplying by. So x here is going to equal 14 times sine of 36, all divided by sine of 31. So we'll type this in on our calculator. So here we have 14 sine of 36. This is being divided by sine of 31. Remember, when you're using the law of sine and cosines, you're going to want to make sure that your calculator is in degree mode. So here we're getting, we're going to go ahead and say approximately 16. 15.97, you could say 0.98. That's close enough for us to say 16. So we can change it from equal and we'll say, okay, this is approximately 16. So we'll take our x, we'll move it just a bit, and we will say this is approximately 16 feet. So now we found a missing leg. Now we need to find the measure of y here. But remember, in order to find the measure of a leg, you have to have the value of the angle across from it, or vice versa. If you want to know the value of the angle, we need the leg across from it. Here we have neither. But we know that in a triangle, angle A, C, and B should all add up to be 180. So here we can subtract 31 and 36 from 180 to find the measure of angle B, and that's going to be approximately 113. Now I can set up my proportion to find the measure of length y. So I'll come over here and I'll say sine of 113 divided by y. This should equal, and I'm going to use the same ratio as before that was given to me. So they gave us angle 31 and the leg length 14. So I'll use that again. So sine 31 over 14. So here I can cross multiply. So I have y times sine of 31 equals 14 times sine of 113. We want y by itself. So we're multiplying by sine 31. In order to isolate, we have to do the opposite of the operation that's being performed. So we will divide by sine 31. So we have y is going to approximately equal 14 times sine 113 divided by 31. Now, normally you would just say equal because it does equal this exact value. But here, since we are going to round, we're just going to say approximate. So let's go ahead and set up our fraction again. So we have 14 times sine of 113. And we will put this over sine of 31. And we're going to get 25 feet. So here y is approximately 25. We'll come back to our triangle, and here we can say approximately 25. So there, using the law of sines, we were able to find all the missing leg lengths and the missing angles. So let's try another example. Let's come down here and look at number 2. So on number 2, we're given this leg length of 17, this angle measure that is in between these two legs, and this third leg measure of 28. So we're given a side length of 17, an angle measure of 87, and this third side length of 28. So here we have an angle in between two sides. So we have side, angle, side. So if we come back up and look at our rules here, side, angle, side, that is here under law of cosines. So we do not have enough information currently the way this is set up to use law of sines. So we're going to have to use law of cosines here to find a missing value. So with law of cosines, we know that rule is as follows. It is a squared equals b squared plus c squared minus 2 times B times C times the cosine of angle A. Now, this looks like a long, complicated formula. I assure you it is not. It is quite easy to use, right? Don't let the size of the formula intimidate you. Now, here you're given leg A, and you're given the cosine of angle A here. So here, even though this says C, we can treat this like it is angle A. And then the way you solve for leg A, that's the leg that is directly across from the angle. So here, while they are labeled differently, we're not going to let that bother us. We're going to say, okay, we're given 87 degrees. So with law of cosines, we can find the leg that is directly across from that 87 by using this formula here. So we don't know the value of A, so we're going to keep that as A squared. You could call it X. It's not going to matter. So here, the B and C, these are the two leg measures that you're given. It doesn't matter what order you put them in because addition is commutative as well as multiplication. So typically what I like to do is the smaller number I'll write first. So I'm going to say 17 squared plus 28 squared minus 2 times 17 times 28. And I will multiply this by the cosine of angle A, and we know that that is going to be 87 degrees. Now, look at the formula. It says A squared. Well, we don't want A squared. What we want is A. So here I need to think, okay, what do I do to go from A squared to A? Because that's a pretty easy problem to solve. I just take the square root. Well, if I do it to the left, I have to do it to the right. So here, I'm just going to say the square root, and this is going to be a long square root, so I'm going to use my ruler, draw that all out here. And I'm just going to take the square root of this on the right. So I have this little handy feature, so I'm not going to write it all out. I'm just going to come here, and I will copy, and I will paste. And we'll make all that fit under our square root. There we go. And we'll make it gray so that we know it is the next step. So this is going to tell us our solution. So A here is going to be, since we are going to round, we're going to use an approximation here. Now, again, the calculator can do all of this. Uh-oh, it seems like I forgot a little parenthesis there. Okay? So we're going to let the calculator do all of this. So we'll go to our calculator, and we're going to say, all right, let's pull up the square root by saying second x squared, and let's type this in. We have 17 squared plus 28 squared minus 2 times 17 times 28 times the cosine of angle A, which was 87 degrees. So again, make sure you're in degree mode, otherwise you will not get the correct answer. And we're getting 31.987. So again, this is very, very close, if we're rounding to the nearest tenth, to go ahead and say 32. So I can erase this, and I know this leg measure here is going to be 32. Now, in order to find the other missing values here, we want to find, let's call angle A X, and we'll call angle Y, or excuse me, angle B, we'll call that Y, since we're looking for these angle measures here. Just because you use law of cosine to begin this triangle does not mean that you are stuck using law of cosine to find all the missing values. Law of cosine just helped us get started. Now, if I look back here, let's say I wanted to find angle A. So you still have a side angle side. So you have all three side lengths. So law of cosine would work perfectly. You could also use law of sines now because you have x, and across from x you have 28, and you have 87, and we know that length across from it now with 32. So we have enough information that we could use law of sines, and law of sines is a little bit faster because we don't have to worry about writing out this formula and typing all that into the calculator. So I'm going to use law of sines here to find the measure of angle A. So here, if I wanted to find the measure of A, I'm going to let this equal the sine of x. And we'll put that over 28. And I'll set that equal to sine of 87 and we'll put that over 32. And we'll use law of sines here to solve this problem. So I can cross multiply, and I'll get 32 times sine x. This equals 28 times sine of 87. Here you want sine of x by itself, so we're multiplying by 32, so we're going to divide. Remember, we always have to do the opposite of the operation that's being performed. So we'll divide by 32. So sine of x equals 28 times sine of 87. This is all over 32. Now, here we don't want sine of x. We just want x because that's the measure of the angle. Remember that sine is a function. So you cannot just simply divide by sine, and you can't just say, well, let's just cross it out. Okay, so the way you eliminate a function, or we're going to say you reduce a function to 1, is you have to multiply by the inverse. So if I do it to the left, I have to do it to the right. So x is going to equal sine inverse of 28 times sine 87 divided by 32. So we'll do that on our calculator. So we'll go ahead and say sine inverse. So you see how you have sine right here, and then up above it in blue, you have this little bitty sine inverse 1. So to get to that, we're going to say second sine. And now we're going to go math and put in our fraction. Okay, so here we're going to type in 28 sine of 87, and we're going to put that over 32. And here we're going to get 60.9. That's going to be the measure of my angle. So I'll come back up here to angle A. I'll erase what was here, and I'll write 60.9 degrees. Now I know that angle A, angle C, and angle B here should all add up to 180. So I'll take 180 and I'll subtract the angles that are currently in the triangle. And that gives me 32.1. So that's going to be the value of y. So let me reduce this, make sure I can fit it inside here. Okay. And here, that's how I'll use law of cosine and law of sine to find all the missing values in this triangle. So let's scroll down and work out our third example. So here you have a side length of 6, a side length of 14, and a side length of 18. So we have side, side, side. So here we're going to want to use the law of cosines in order to find the missing angles. So let's write out our law of cosines. That is a squared equals b squared plus c squared minus 2bc times the cosine of angle A. So here I'm going to call angle A x, and then across from angle A will be leg A. And then for B and C, I like to call the smaller number 6, I like to call that B, and then the larger number 18, I like to call that C. It doesn't really matter as addition and multiplication are commutative. So let's go ahead and plug this in. We have 14 squared equals 6 squared plus 18 squared minus 2 times 6 times 18 times the cosine of angle A. So here we want to isolate cosine x. So that means all of these other numbers, they need to be moved over to the left-hand side of the equal sign. So what I'm going to do is I'm going to go ahead and square, add, and multiply these numbers out. The numbers will be larger, but the problem itself will look simpler. So that's going to give us 196, 6 squared plus 18 squared. This is going to give us 360. 12 times 18, let's do that on our calculator. That's going to give us 216. Now here, I want to show you a little example, one that looks a little bit simpler than this. So let's say if I had 5 equals 6 minus 2y. and I said, I want you to solve here. It's the exact same thing as what we're given here. So the trap is people will say 360 minus 216. And then they'll say, oh, well, this should be, let's do this real quick. 360 minus 216 is 144. So people will say, oh, this is 196 equals 144 cosine x. Okay, well, you can't do that. You can't combine a number with a number and a variable. That's like over here. You can't say 4y. All right, that's wrong. We have to say, okay, here we have a two-step equation, a constant and a variable. So we need to move the constant 6 and then divide by the number that's in front of the variable. We're going to do the same thing over here. So we should subtract 360. So let me draw my line here. 196 minus 360, that gives me negative 164. This equals negative 216 cosine x. And I'll divide by the number that's in front of cosine. So here, we'll draw a line, and we will divide by negative 216. So I'm going to rewrite this so cosine is out in front. And I have 164 over 216. So in order to get rid of cosine, you're going to have to multiply by the inverse. So let me take this and move it over to the right here. And I'm multiplying by inverse cosine. So x here is going to be approximately, let's type this in on our calculator. Let's go second cosine, and then we'll say 164 over 216. And that's going to give us 40.6. Now, I don't want you to think that I've just forgotten about the negatives. I know, because like Mr. Phillips, we started with negative numbers. Remember, a negative divided by a negative is a positive. So I did not forget about that. I just wrote it as positive because I knew a negative divided by a negative gave me a positive. So here I have 40.6. So I need to find the other missing angles. So here we can say y and z. Now, it may appear that you have some options, like you have 40.6 and you have 14. So you could say, oh, well, let's do a law of sines. Let's say 40.6 over 14 equals sine of y over 18. I caution you on doing that only because you only have one angle in the triangle. Anytime you only have one angle and you have multiple sides, you run the risk of running into the ambiguous case. So if you don't know about that, you can watch one of my prior videos. But if possible, I would try to use the law of cosine for a second time here, because law of cosine is always going to give you the answer in the standard case, and you won't have to worry about the ambiguous case here. So we're going to rewrite our equation for the law of cosines again. And then we're going to say 18. So since we're looking for y, we're going to say it's going to be 18 squared. And then we'll use 6 and 14 as our leg measures. So I have 18 squared equals 6 squared plus 14 squared minus 2 times 6 times 14 times the cosine. And here we'll call that y. So we have a problem that's just like one we just finished. So we'll go ahead and square these numbers out, add these together. So 12 times 14, that's going to give me 168. And then here we're going to move the 232. We will not combine these. We will treat this just like a two-step equation. So here, let's go ahead and subtract. 324 minus 232, this gives us 92. We'll bring down the negative 168, and we will divide by the number that's in front of cosine. We will divide by the leading coefficient. So here we have cosine y equals negative 92 over 168. And I'll go ahead and put my negative out front here. So we know to eliminate this cosine here, we're going to have to multiply by the inverse. So I'll say inverse cosine and inverse cosine here as well. So here we're going to get y is approximately, and let's type this in on our calculator and see what we get. So we have negative 92 all over 168, and we get 123.2. So this is going to be the measure for angle B here, 123.2. So let's see if I can make this fit. There we go. Now I do want to show you what this would look like if you're using the law of sines. So if I said sine of 40.6 over 14, and I said sine of y over 18. Let's see if this method gives us the same solution as the law of cosines. So we have 14 sine of y equals 18 times sine of 40.6. So we're going to go ahead and divide by 14 and then take the inverse. So I'll kind of skip writing all that down. So y should be the inverse sine of 18 times sine of 40.6 all over 14. So here we should get 123.2 just like we did before. So let's see what we get. So I'll go ahead and type my information in here, 18 sine 40.6 all over 14. And now we get something different. We get 56.8. So we don't get 123.2. So why is this? You have the possibility of two triangles here with these following measures. One triangle, the standard case, would have angle B having 123.2 degrees, and the ambiguous case would have angle B having 56.8 degrees. So make sure anytime you have two sides in one angle, if possible, use the law of cosines. If it's not possible, we'll just have to work our way through it. So let me go ahead and shrink this a little bit so it doesn't get in the way of our notes here with law of cosines. So we have one final example here. Here, this is going, you have one angle and you have two side lengths. So, let's spell this backwards. There we go. We'll say SSA. Let's not spell it the other way around. So with two sides and one angle, you would like to use law of cosines if possible here. But unfortunately, we don't have enough information. So in order to use law of cosines, you need an opposite leg like here, and then you need the value of the legs on either side of the angle that you're given. So in this case, we couldn't even find the measure of angle B if we wanted to. We couldn't find the measure of angle C because we have 9, but now we have a B leg, but we don't have a C leg. So we still don't know what this is. So in this setup, you cannot use law of cosines, even though we want to. We're going to be forced to use law of sines here. But what we want to do is we want to check the solution we get, and we want to ensure that there is not a possibility of two triangles here. So I'm going to say sine of 31 over 15, and I am going to set that equal to sine of x over 9. So across from angle x is 9. And then here we will cross multiply. So I have 15 times sine of x equals 9 times sine of 31. Here we know that we're going to divide by 15 because we're going to do the opposite of whatever they're doing. So x here is going to be the sine inverse of this fraction, 9 sine 31 all over 15. So I'll type this in on my calculator. And I'm going to get 18. So the measure of angle C is going to be 18 degrees. Now, what you're going to want to check on this to make sure that you don't have the possibility of the ambiguous case. 18 degrees, we're going to assume that's the standard case. So we want to check and see, okay, is there going to be an angle for the ambiguous case? So what you would do is you would say 180 minus the angle you just found. So 180 minus 18, this gives us 162. So in the ambiguous case, you would have an angle of 162. I want to know, would that even work in this triangle? So if I said 162, no, that's not going to work because they told you A is 31 and 31 plus 162 is larger than 180. So there's not going to be an ambiguous case here. Angle C is just going to be 18 degrees. And now that I know the value of angle C, I can take A and C and subtract them from 180. And that would give me the measure of angle B. And that's going to give me 131 degrees. Now I can use law of sine to find the missing leg Y here. So leg length AC. So I can say sine of 131 over Y. This is going to equal, I'm going to use the values they always give us. So I'm going to say sine of 31 over 15. And now here I will cross multiply and solve for y. So I have y times sine of 31 equals 15 times sine of 131. And y is going to be 15 times sine 131 divided by sine of 31. Okay, let's go to the calculator and get this typed in. And we're getting 21.98. Since we're doing the 10th on most of these, this is perfectly fine to go ahead and say 22. So here, side length AC, we're going to say is approximately 22. And there you have it. There's 4 examples of deciding when and how to use the law of sine and or the law of cosine in order to find missing angles and leg lengths in a triangle. If you like this video, be sure to give it a thumbs up. Hit that subscribe button and pass this video on to your friends. If you have any questions, please leave them in the comments and I will do my best to answer them and get back to you as quick as I can. All right, that's it for this video and we'll see you in the next one.